This is now lecture 3.2, and what we're going to talk about in this segment is arrays in the context of our motivating problem of we want to draw polygons, we want to have efficient storage, and we want to be able to move them around. So let's now speak to the issue of storing polygons. So the means by which we would like to store polygon information is in a Java construct called the array. So an array is a contiguous collection of data items of one type. And arrays are in just about every programming language in existence, unless the language is super simple. It allows you, what an array does, is it allows you to structure data. And one of the key structuring ideas is to have a sequence of identical typed items accessed by an index number. So bear that in mind as we move forward. So an array stores lists of values and you access items by index number. So let's go back. We've seen this diagram before. Here's the effect of creating an int variable. So this is a review from an earlier lecture. And so here in this thing, we're creating a single integer named anint. We set its type to be int, and that creates this yellow box, which is 32 bits. Its name is anint, and its type is int. And we can stick a value in it, an integer value, and with this assignment, that has the result of, behind the scenes, in this memory storage represented by this yellow box, a 3 shows up there. And of course, because this is Java, if you try to assign something else to anint, you will get some kind of error at compile time telling you, no, you've got a type mismatch between this string hello and the integer type of this variable anint. Now let's show what happens when we create an array. So when you create an array in Java, you do it in 2 stages. The first stage is to declare a variable that is of type integer array. And you specify that it is an array through the use of specifying first the type of thing that the array will hold and open and close square brackets right beside each other without any other info. So this is saying this variable int array has the type integer, and then just the open close square bracket says it's an array. And what this does is creates a piece of storage in the memory, in the back room as it were, that is ready to receive array information. It isn't an array yet. This next stage creates the actual storage for the array. So here we then say int array equals new int5. So new is another Java keyword that says I would like to create a new chunk of storage. In particular, the chunk of storage I would like to create is an array of integers that is of length 5. Okay? So there's a little bit of redundancy here in that we have this int array kind of type without any details, and then int with the detail of how big it is here. But that's Java for you. There are elements of verbosity in it. So once int array has received new int5 in this case, the Java machinery goes off and creates storage for 5 integers in a row and initializes them to 0. And that now enables you to be able to store items in this array. So here's how we store an item in an array. We say int array with an index number. And this index number must be between 0 and 4 inclusive. And we know that because 0 is the lowest index number. And it has 5 elements, so the index numbers run from 0 through 4. So we're saying here int array 0 equals 3, and what that has the effect of doing is storing at this location the value 3. To set another element, we're saying for this example int array square brackets 2 equals 5, and what this does is it goes to the index item 2, which is the third one here, and stores the value 5 there. Now you might be wondering, why 0? And the way to think about Java arrays and C arrays and C++ arrays is that think of this index here as the offset from the beginning. The amount of steps you will add from the beginning of the array to get to the position that you want. The first element, therefore, is 0 steps from the beginning element, and that's the one we're using here for the first item, and 3 is stored there. The index 2 is 2 steps away from the beginning, 1, 2, and that puts you in this spot here, which is the third one along. Alrighty. So now let's use the arrays. So here's a little program that uses the same values that we saw earlier for the polygon in lecture 3.1. And what we've done is, instead of showing the data in pairs surrounded by vertex calls, what we've done is we've created an array, integer array named xvals, meaning x values, and we've assigned it with a concrete assignment shown here. We have open brace, and then the first array element, the second array element, third, fourth, fifth. And we also have another array named y values, which is where the y vertices are going, values of the vertices are going to be stored. And again, it's initialized the same way with this constant set of values: 50, 10, 40, 60, 80. And you'll recall that the original locations, the first vertex was 1050, the second was 2010, etc., etc. Now, what we can do is we can, once again, issue our begin shape call. I've left out polygon in the interest of brevity. And then I can use our friendly for loop, where we could declare the integer value I that we're going to use and set its initial value to 0. We're going to loop until while I is less than xvals.length, and I'll tell you what that means in a sec. And then we increment I. So this is a very short way of saying add 1 to I. Instead of saying I equals I plus 1, we just say I plus plus. Then we can simply, within the body of the loop, issue vertex xvals sub I, yvals sub I. That means take the ith element from xvals and the ith element from yvals. And because we're looping from 0 through 4 inclusive, we will first do a vertex call for these two, then for these two elements, these two, and these two. And then finally, once the loop is complete, we issue the call end shape close. So let's show what that looks like in our processing window. So here's once again our processing window, and in this piece of code I have the thing we had done in the previous lecture, which is begin shape polygon in those vertices, 10, 50, 20, 10, etc., etc. And you can see 10, 20, 30, 80, 40, 10, 20, 30, 80, 40, and the y values are in the y array. So what I'm showing you here is completely redundant. We're going to draw the same thing twice, but in this one I have used the code to store the data that is the shape of the polygon. And in here, I have a data structure, 2 arrays that are storing the geometry, and the process for drawing the geometry is here. So let's just press play. And you can see, once again, there's our polygon with its fun shape. Okay, let me just do one little thing and set the fill value here. Press play again, and we'll get a red polygon to indicate that indeed, because I set fill here, this is the one that is done by the array access thing, the for loop in the second round. And I'm just demonstrating that indeed the thing's worked. In fact, I can take all this stuff, delete it, play it again, and we get the shape we want. Okay. So one last little point. Let me go back to the slides. One of the things that Java has built into it is provisions for making sure that you access arrays correctly. So one element of that Java error prevention is, first, you're not allowed to access array elements where the index is less than 0 or greater than or equal to the length, the size of it. You can only access elements 0 through to length -1. And one of the conveniences of Java arrays is there's a means of querying the array as to what size it is, and it's done through xvals through the array name dot length. And what that does is it just simply reaches into the extra data that Java arrays have and returns back to you, the programmer, the information about how big the array is. And it turns out this is incredibly convenient. If some other piece of code passes your code an array, you don't have to also be passed the array size or anything else. You can query the array directly. And this thing of querying the array directly through this well-understood means of putting dot length after the name of the array is an object-oriented technique. That is to say, each of these things, x-vals and y-vals, each of those two things is an object of integer array type that has enough information for you to access it without having to access other weird pieces of information or other variables that might be different from programmer to programmer. This is a standard way of telling you the array size, and trust me, it's a real benefit to be able to do this. The other thing I mentioned was this thing about protecting you from accessing beyond the array, is that you don't have to worry if indeed you do access beyond the array, because if you do so, what happens is that Java has a mechanism called exceptions, such that when you do use an array index that's wrong, less than 0 or greater than the size of the array, it'll do this thing called throwing an exception, which alarms you, the programmer, to say, no, you there's an error here, you went beyond the array size, and you need to fix it. Okay. So, now let's just use x-vals and y-vals a little bit more to draw the shape that we have elsewhere. We'd previously spent some time explaining how arrays work. Now let's just talk about using the array information to draw that shape in a different location. And what I'm going to do is I'm just simply going to duplicate this thing. I'm going to put the same code before the fill call that was green. And now, in the second, what is now the second one, I'm just simply going to add 10 as was shown in the slides. So let me just switch to the processing window so you can see what I'm doing. So what I did is I copied this stuff to there, and now in the second one of these things, I am going to add 10 to each of the vertex values, the x vertex and y vertex. And so the first one of these things will use the standard fill color of white, and the second one will issue the fill color of red, and will also move it plus 10 in x and plus 10 in y. So let's just see that. Okay, so there we go. So this is the original shape that we had. And here's the second shape, which is drawn on top of the first because it is drawn afterwards. And we know it's the second one because we set the fill color to be red for the second one. Okay, now bear in mind, let's say you wanted to move this array around. Well, one of the things, move this shape around, just sort of animate it moving across the screen. There's a number of ways you can do this. The way I've shown you here is a little bit clumsy. That is to say, changing this value as, constants, that's certainly super clumsy, or changing it to variables, putting all this stuff inside a draw method and changing it to variables, that's also a little clumsy. What we're going to do next is illustrate how we can do that with a little bit more finesse. So that wraps up the segment of lecture 3.2 about arrays.